You should always press the second.
Yeah.
I read through it and was trying to solve it.
Maybe you need to understand what the question means. I'll explain what the question means in a little bit, but you should try to think about it.
I was thinking about it, yes. I just don't really get, like, is it possible to get a bag with 1 kg of sugar? Because can't you just put 1 kilogram of sugar into the bag?
But how do you know it's 1 kilogram?
Oh.
This is the only device you have to measure the weight.
Oh. What about the metal weight?
Yeah, so the metal weight is your starting point.
We should probably weigh the sugar first, then.
You have unlimited sugar.
So, like...
You have unlimited sugar and unlimited bags.
In this way, the bags.
So, like, maybe you can think, can you get a 6 kilogram bag of sugar? Oh, just do a pen.
Use this.
Yeah, use the paper right on. Hmm?
Yes, how much is that?
Okay. What chips?
The these flavors. Yeah, this is good. It's just a little sour. Okay. One bag. Some sugar. And here we go.
Alright, 1 more minute, guys.
So you can have unlimited amounts of weighings.
Yeah.
Can we put the metal weight in a weightless bag?
Oh, you could, but then like you just get a bag of weight. 6 kilogram bag of metal.
Like the metal weight weighs 6 kilos.
Yeah. Okay, let me just talk about this question for a little bit because
I'm doing a strategy. I'm doing the what we know strategy.
all right, Blake, can you hear me? Lucas,
Yeah, yeah, I
can you
can.
hear me?
Yeah, I can hear you.
Okay, cool. All right, stay in Zoom, but I'll give you the YouTube link just in case you want to rewind. Okay.
I already also yes, I can hear you.
Oh, okay. Yeah, for some reason
By the way, I already got the YouTube link.
Oh, you're already on YouTube.
Yeah.
Well, that's good. Um. Sorry.
Wait. Do you have? I think you know how the bag is 1 kilogram if you put it on one of the pans, so it turns into 4.
Yeah. All right. So let me be clear about the question, okay? Because this is sometimes a bit hard to understand. So I have a scale, right, like this. Yeah. That's a pan, and then here I have another pan, okay? Yeah. And then and the scale kind of like maybe balances on something like a triangle or something, right? And they balance if this weight is to this weight, 3 is to 4. So like, for example, I have 6 kilos to start with, yeah? If I put a block in here, let's say that's 6 kilos, yeah? Yeah. Okay. So I'm allowed to try to put something in here to make it balance, okay? So let's say I put it on the light side, okay? So it's not like 6 is not going to balance 6. Does that make sense? Because this scale is special, yeah? Okay. But what can I put here to balance the 6?
A 4.
Uh
2 3s.
so a 6 is 2 times 3, right? Yeah?
Yeah.
So I need 4 on the other side to balance 6, yeah? So if I have 2 3s over here, how many 4s do I need? No, I have 2 3s over here. The ratio is 3s to 4. So if I had a pan here, right? Okay. If I have 3 kilograms over here, right? Yeah. Then the question says I need 4 here and then it's balanced. Understand? It's not a normal scale where it's 3 balances 3, okay? So here 3 needs to balance 4.
So you have
That
to
makes
be
sense?
8.
Yeah, it's actually not that hard to design a scale like this. You just need to make like it's like a seesaw, you know, like a seesaw.
Yeah.
You just need to make one side longer than the other side. Then it becomes like this kind of scale. Yeah. Okay, so if I need, so what did you say? You said a number.
8.
8. Yes. So if I put 8 here, yeah, now it balances. That makes sense. Okay, and in the question, what I can do is I can put a bag here which weighs nothing, right?
Yes.
And then I can pour sugar into the bag until there's 8 kilos. Yeah? Okay, and then it balances, okay? And then I seal the bag off, yeah? And then I'm sure I have an 8 kilogram bag of sugar now. That makes sense?
Yes.
Okay. So at the moment, so before I started with just a scale, a balance, yeah?
Yeah.
Are you listening? So I started with a scale and a 6 kilogram weight, yeah? After doing this, I now also have an 8 kilogram bag of sugar. Okay? That makes sense?
Yes.
And the question is, if I keep doing stuff like this, so I can get a whole bunch of different bags of sugar, right?
Yes.
And I can put the bags of sugar on any end of the scale I want, and I can pour sugar. I can make new bags of sugar on any end of the scale I want. Okay. And the question is, if I keep doing this, yeah, can I get a bag that I know to be exactly 1 kilogram of sugar? Does that make sense?
What?
So if the question was instead of 8 kilograms, if the question instead of 1 kilogram asked for 8 kilograms, yeah?
Mm.
What would be the answer?
Yes.
Yes, right? Because we got this just then, right? Okay, so let me ask you another question. What if the question was 6 kilograms? Can you do that? If it was 6 kilograms, can you do it?
Yes.
How? I don't like instant answers, okay? Can you get 6 kilograms?
I don't.
Then why'd you say yes? Okay, so I'd rather you think than talk, okay? Okay, do you know how I get like a 6 kilogram bag of sugar?
It can it be 4 and 6?
4 and 6 doesn't make the right ratio, so 4 is 2 is to 3. Like 4 to 6 is 2 is to 3. You know? Yeah. Okay, so for example, to get a 6 kilogram bag of sugar, yeah? What I can do is I make the 8 kilogram bag of sugar, yeah?
Yeah.
Okay, and then I remove this 6 kilogram weight, yeah? Right? That makes sense?
Yeah.
And then I pour sugar into a bag here until until it balances, yeah? And because we balanced it with 6 kilograms of metal, now you have 6 kilograms of sugar, yeah? What's heavier? A kilogram of stone or a kilogram of feathers?
Feathers. What? That's a trick question. Well, they're both the same way.
Both the same way.
It's all 1 kilo. It's all a kilogram.
No, it's feathers. That's the trick question, isn't it? I don't know.
The 1 kilogram of each material. 1 kilogram.
But the joke keeps going, yeah.
But isn't the trick that the feathers are heavier?
I think the joke goes like this. What's heavier, a kilogram of stone or a kilogram of feathers? A kilogram of stone, because stone is heavier than feathers.
No, the joke goes like this. I think the trick question goes like this. Which is heavier, a kilogram of stone or a kilogram of feathers? Feathers. It's a quick trick question.
Okay.
I think it's both since they're both 1 kilogram.
Yeah, so sit down. Okay, so now we have 2 bags of sugar, right? Yeah.
Yeah.
So having more bags is potentially more helpful, yeah? Okay. So we can get 8 kilograms and 6 kilograms, yeah?
If we take away the 8,
Yeah.
so it down to no.
Yeah, and we're allowed to make as many 6 kilogram bags as we want, okay?
Yeah.
So we can make like 10 of these this way, yeah?
If we get 6 and we
Goblin.
pour in 4, so it gets to half. Can we get a bag of sugar that's 4?
Goblin.
So you sort of can, but you can't do it the way you're saying, because you don't know when to stop pouring, because you don't know when to get to 4, yeah? But if you already had a 4 kilogram bag, you could just put that in there and then start pouring. That makes sense?
Yeah.
So for example, another way what you could do is, so if you put the 8, so imagine if 8 was on this side now, yeah? So you have 8 on the lighter side, yeah? Okay. So here we have 8 here, yeah? Okay. Okay, it's a bit of an awkward number, maybe, but, okay. What do we have to have on this side to balance it, yeah?
6.
This is the lighter side now, No.
Mm,
Yeah, so this is not an easy question.
El Goblino.
Okay, so maybe to make the question a bit easier, let's make this 12, okay?
El
So that's 12, yeah? So Michelle, don't make any noises. Spend all your focus looking at the question.
16.
So this one's easier because it gives you a whole number, yeah? So to make this one balanced, you need 16, right?
Yep.
That makes sense? Okay. But what you can do to get 16 is because you had two 8 kilogram bags, right? You're gonna have as many 8 kilogram bags as you want, yeah?
2
Right? You also have 6 kilogram bags, yeah?
Yep.
So you could put like a 6 kilogram bag here, right? Yeah. And then you can put an 8 kilogram bag here. That makes sense?
14.
And then you can just pour sugar and make a new bag that makes up the difference, yeah? So 14, we want an 18, right? What do we want?
60.
16. Okay, we want 16. So 14, we need 2 kilograms here, yeah?
Yep.
So this allows us to create a 2 kilogram bag of sugar. Does that make sense?
Yes.
Does that make sense, Michael? Does that make sense, Michelle? So now we have 8 kilograms, 12 kilograms, 6 kilograms, 2 kilogram bags of sugar, yeah? The question is, can we have a 1 kilogram bag of sugar? Yeah?
Well, I think we need a 3 kilogram bag.
Okay, can we get a 3 kilogram bag? Do you know how to get a 3 kilogram bag of sugar?
12. And no. So we get a 4 kilogram bag.
Yeah, how do we get a 4 kilogram bag of sugar?
We can do it by using 12.
12, how? So let me just say we have 6, yeah? We have 8. We have 2, yeah? And I guess we have 12. And then what are you suggesting? We want to get 4.
Yeah. 12 and 8.
Okay, so let me give you an interesting idea. Okay, so because I know how to make a 2 kilogram bag, right? Yeah. Can you see? I don't actually need to make a 6 kilogram bag anymore because once I got a 2 kilogram bag, I can just use 3 of these as a 6 kilogram bag. See what I'm saying? So if I know how to make a 2 kilogram bag, I can just make lots and lots of 2 kilogram bags, right?
Yeah.
So that means I can make any even number of kilograms I want. You see?
Yeah.
That makes sense?
Yeah.
So that means I can get 4 by just having 2 kilogram bags, right?
So that means you can make 60,
I can make 60, yeah.
even though it's a really big number.
Yeah, I just get 2 kilogram bags. I can just do that
And if you
process.
know how to make 1, you can also do all the odd numbers.
Yeah, if I know how to make 1, I can do all the numbers, right?
Yeah. 1 equals all the numbers.
Okay, so now we can try to make 3, yeah? How can we make 3?
2 plus 1.
You don't have 1. You only have 2.
No. Equal.
You don't. That's the whole question. How do you make 1?
3. I have idea. You split your 2.
Yeah, but you don't really know how much
Like you cut your bag in half, and then you have one, take one, and then make the other one 2. Wait, okay, 4. Okay, get that one bag, cut it off. Your other one bag, you throw it away, and you make another bag of 2, and then 3. Ta-da! You cut your 2 with a knife.
you get the knife from.
You make it
How do you
stone, leaves,
Where'd you get that?
nature.
Nature is everywhere.
I know how to get 3.
How?
Okay, so you have your 2 bags. You use a knife and cut it in half, and then only 1. Throw one of them away and make a 2. Easy 3.
No, that's really dumb, okay? And also, if you had the 1, you would just be done, yeah?
12
Okay.
and 6.
So your job is not to be funny, okay? And most of the time it's not funny. Funny needs clever or something.
12 and 6.
12 and 6? What does that mean?
So if you use 12, so you have one of 12
Yeah.
and one with 6.
Yeah. Which one was 12? Is the heavier one or the lighter one?
Heavier.
Okay, and then you have one with 6, yeah?
Yeah.
Yeah?
Basically, they're going to be balanced. So
How are we going to balance them? So remember the ratio is 4:3, right? Yeah.
Oh. And then plus 6 and 8. Wait, if we know how to make 2 bags, can we take away 2 kilos from the bag?
What do you mean?
Like, can we take away like 2 kilos from 12 kilos of sugar one by one?
You can, but what's the point of doing that? Because you can get all the things you can get from taking away 12 minus 2 with all the just plussing 2's. Okay, I want to say something. I don't know. This thing is a good idea, but I don't know if you realize it's a good idea. Okay? See, because 12 here, right? It's 3 lots of 4's, right?
Yeah.
Yes? Okay. So to balance 12, you need 3 lots of 3's. Yes?
9.
Which is 9, right?
Yeah.
That makes sense? Okay, but you have 6 here, right? That makes sense?
Yeah.
So if you have 6 and you need 9 to balance, right?
Just had 3.
Then you can make 3, right?
You can keep pouring until it gets even.
You can pour until it balances and then you get a 3 kilogram bag, yeah? That makes sense? Okay, the way that I expected you to get 3 was if you had 4 here, yeah? Which you can do with 2 2's, right? Yeah? Then you get 3 to balance this 4, right? That makes sense? Like you have 4, yeah?
Yeah.
So you need 3 to balance 4, yeah?
Yeah.
Because that's how the balance works.
Yeah.
So then that's how you get your 3. You keep pouring sugar until it balances, and that much sugar is 3 kilograms.
Oh.
Do you agree?
Yeah. Yeah.
Okay, so that's good. So now not only do we have all the even numbers, yeah? We actually have 3 as well, yeah? So one way to write all the even numbers, this is maybe...
Wait, if we have 3, we can get most of the numbers divisible. We can get all the numbers divisible by 2.
Yeah, I mean, there's lots of ways to write it. There's some fancy notation, like the set of all the even numbers, like plus and minus. You can write like this, but probably
Now we have
won't use it till later.
to all the
Okay, or
numbers
the
divisible
positive
by
even
3.
numbers, you might have like 2
We have access to
times the
all
natural
the
numbers.
divisible numbers
Okay.
by 3.
Well, maybe don't worry about that. So we got all the even numbers and we have all the 3's, yeah?
Wait, so we get...
And as Michelle said, we also get all the multiples of 3, yeah?
Yeah.
So we have 3 now, yes?
And we also have... Wait, what if we like... Wait, we can just minus...
2 from 3 to get 1.
How do you do that? How do you do it on the scale?
3 and 2.
So we basically got everything except for 1 basically.
Yeah.
Everything. We just have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah, I mean, if we have 3, can you see we have 5 as well? We also have 7.
Because we have 2.
So we have now every number except for 1, yeah?
So we can use... Wait. Since we have 2 and 3, does that mean we can plus them together?
2 and 3, yeah, you get 5, yeah?
So we have all those numbers then. Got all the numbers except for 1. Right?
Yeah.
3 and 2. Wait, but if we make... You know how to make a 3 bag, then how do we minus 2 if we didn't put 3 bag? By using 2's. And 1 is lower than all the numbers. What can...
What can we make something go down?
I think these type of questions, like, it is possible to get 1 kilogram of sugar, they just want you to.
I mean, even if it's not possible, I would want the young people like you guys to try to prove it's possible. Does that make sense?
Yeah.
Because that's really the direction that you can do. Okay.
Yeah.
And usually, even if you're proving it's impossible, you start trying to make it possible. Does that make sense? Only when you realize it's actually it's pretty hard that you start thinking it might actually be impossible. You know?
Yeah.
But a lot of people think it's like they think, oh, it's impossible. Like it's like they're just guessing the answer. You know what I'm saying? It makes
Yeah.
little sense.
Yeah. But some things can be impossible.
It can be impossible, but it's not impossible just because you want it to be. Okay.
Yeah, so you can't. So you're saying that you can't just go like, it's impossible.
Yeah, you have to prove it's impossible if it's actually impossible.
It's
Okay.
impossible.
Alright, so let me show you this. This is pretty cool, okay? It's actually the thing about this is it's kind of right in front of your eyes, okay? So this is in front of you the whole time. And that's what makes maths very very nice, okay? None of this was like hidden from you, okay?
Yeah.
So we just got 3, yeah?
Yeah.
Yeah. Okay, so let's put this bag of let's take this 3 kilogram bag and put it to work, okay? So let's put it on the scale, yeah? Yeah. Okay. So if we have a 3 kilogram bag here, right? And it's on the left, the light side, okay? What do we need here to balance it?
4.
4, yeah?
Yeah.
Okay.
2 2s.
So we need 4 kilograms to balance here, yeah?
Yeah.
But we already have 3 kilograms, right?
Yeah, so, and then the heavy side is gonna go down by 1 kilogram since 4 balances it and 3 does not. So
Yeah.
you make another bag and you fill it up until it gets balanced. So that
Oh.
would be 1 kilogram.
Oh.
You see? Does that make sense? So now now you can actually balance it by just adding 1 kilogram, right? Okay, so the answer is yes, you can do it, and this is how you do it. If you want a challenge for homework, this is probably not for you guys. You need like maybe much older students. Try to prove that. Try to do the same question. So this is the one we ended up doing on Monday class. If you're not allowed to pour sugar into a pan that already has a weight in it. So if you're only allowed to put sugar into empty pan, yeah, how would you do this question? Okay, and so it's much harder. Okay. Do you have any questions about that? Yes.
So if we have those numbers, does that mean we have all the numbers except for 1?
No, we have 1 now.
We have?
Because here we need 4 kilograms to balance it, yeah? And we already have 3, so we put the 3 in, and then we just need to, when it balances, we know we have 1 more, yeah? So we have 4.
Now we can minus.
So we get 1, yeah.
And then we
Oh,
can,
so we have all the numbers.
and then we can
Yeah.
minus the 1 kilo, and then we have.
We need
Yeah,
one-
so this effectively lets you do minusing, okay? Yeah?
Yeah.
So if you just got
So-
2 3s, and so you could just keep on making 1s.
Yeah.
I found
Yeah.
1.
So basically, if you want, you can actually prove that you can subtract any 2 weights that you can already form, yeah? And that'll make it easier. Then you don't need 3 and 4. You could do any 2 numbers that are next to each other, yeah?
Like,
And the way you subtract is, you know, the way you get 1 weight, you just make that happen, and that weight's here, right? But instead of putting that weight there, you put the weight you want to subtract there, right? So then to get the weight that you want, you have to put the difference here, and that'll be how you minus. Okay. Yeah. So that's a pretty nice question, right?
Another question.
Yeah.
You students saw this?
Yeah.
Oh, they also saw it.
Yeah. So this is the kind of question that if you enjoy doing, you should come to the Tournament of Towns A level. Okay. But keep in mind, if you don't solve it, you'll get 0 points. But you shouldn't be too afraid of that.
Wait, are these questions?
I'm talking. Be quiet. Okay. Wait till I finish talking, then you can talk. All right. So once you can do this kind of question, that's already pretty good for beginners. Okay. And the 7 questions, the 7th question gets really hard. Okay. But this one, depending on what topic it is, you can still have a chance. And it's this Saturday. Okay. So if you want to do it this Saturday, so for example, you're doing it, right?
Yeah.
So you're doing it, and you'll most likely get 0, but you'll have fun trying to solve this problem. Yes?
What about? Can we try the one the dual question?
Yeah, but I'm talking about this right now. Yeah. Alright, what were you gonna say?
So you're saying these questions are from the Tournament of Towns?
Yes.
Oh.
Okay. Okay, so I encourage you to ask a question at the end of every topic. Okay. Oh, Lucas, do you think you'll be able to make it to the Tournament of Towns? Lucas?
What if you go 2 and 2?
2 and 2. What do you mean?
So
Maybe.
2 of them, one on the light and one on the heavy. They're both 2s.
Yeah.
Does it still work?
Yeah.
So let's see. So your question is if you 2 kilos versus 2 kilos, yeah. And then what do you do?
So does that work?
Work for what?
To getting 1.
Well, so in terms of this, okay, so if it's 3 to 4, yeah. So if this is on the 3 side, yeah. So how would you get to 2 from 3? You will divide by 3 times by 2, right? Yeah. Okay. And if you were to get to 4, divide by 3 times by 2. Well, that's, I guess, that's 8 over 3, yeah? So 8 over 3 minus 2 is what you get on this side, okay? If you did it the other way, 2 is half of 4, yeah? Okay, so 1.5 is half of 3, yeah? So this is a little bit more than too much to balance, yeah? But then you could do it again, you could put another one here, right? And then then you need 3 to balance, yeah? And then if you need 3 to balance, then that's another way of getting 1, you know? That makes sense? Yeah, I think generally speaking, in the long run, every time we talk about something, like we're going to talk about something else after this, yeah? Before we talk about something else, you should ask a question, okay? That makes sense?
Yeah.
Because the people who don't have any questions doesn't mean they understand, okay? Even if you think you understand. Yeah, so... Okay, so that's that one. Alright, so... I mean, I can quickly explain. So there was this other question. Remember this question? I don't want to take too much time, but I want to quickly explain how that works, okay? Just quickly. So quickly explain one strategy you could do, okay? So what can you do? So you got like... So we did this last week, so I'm not going to explain the question too much. But basically, you got a bunch of like... bricks, and you want to stack them on top of each other, yeah? Okay, and you start with 50 white bricks and 50 black bricks, okay? And then what you want to do, so the white bricks, a single brick has the top white brick and the bottom white brick. They're both white. Yeah. We want to. What Bob wants to do is to keep it like that, whereas Alice wants to mess it up. Okay. So for example, Alice will have to put a white brick on top of a black brick. Okay. Or the other way around. Yeah. So then you get this stack where it has a different color top than the bottom. Yeah. And that's what. Let's define that to be messed up. Okay. What Bob wants to do is to eliminate these messed up stacks. Okay. So how does Bob deal with this messed up stack? Well, it's very easy. He can just put another black one on top. Yeah. That makes sense.
Yeah, and they're gonna keep on going.
And then it's gonna now it's got the same color top and bottom. Yeah. That makes sense. So basically, then Alice basically does something again. Okay, and then Bob cleans it up again. Yeah. That makes sense. Okay. And what happens is when you get down to like 4 tiles, okay, they're gonna be like pretty tall stacks, okay. But the point is they're gonna have the same color top as the bottom. Yeah. Okay. So there's 4 of them. I've just drawn 2 of them with black and black. Yeah. Okay. And then there's another 2 with white and white. Okay. You see? That makes sense?
Yeah.
Okay. So another 2 with white and white, okay, and it's Alice's turn, okay? So she basically doesn't have a choice because these are all pretty much identical. So she basically puts a black one on top of a white one. Yeah? That makes sense?
Yeah.
Putting a white one on top of a black one is pretty much the same. Yeah? Okay, so you end up with black, something with a black top and a white bottom. Yeah? Okay. And then what Bob does, okay, is does the opposite thing, okay? So Alice makes something with a black top and a white bottom, yeah? By putting this one on top of that one, yeah? Okay. What Bob does is puts the white one that doesn't get used on top of the black one that doesn't get used. Okay? And that has a white top now and a black bottom. That makes sense?
Yeah.
Okay. So now Bob does this and it's Alice's turn, okay? So can you tell me what Alice can do now?
Put the not used one on top of the other one.
So there's only 2 left, okay? There's no unused ones now. But these are the only 2 there are, okay? Well, we had 4 and then we did 2 moves and now there's only 2. Okay, what can Alice do now? So if you only have 2 towers, there's only 2 options. You can stack one on top of the other, or you can take this one and stack it on top of that one, right?
Yeah, but you can't do that because if you stack that one on top of the other one, then it's gonna be a white and white, and if you stack the other one on top of the other one, then it's gonna be a black.
That's right. And so what's the conclusion then?
So yes,
Bob is guaranteed.
to win.
So Alice loses, right? Because Alice has no moves.
Yeah.
Yeah? That's how the game was defined, yeah?
Yeah.
So Alice lost. Yeah?
Yeah.
Does that make sense?
Yes.
Okay. So this is like what I mean. You need to ask questions, okay? Because there's actually lots of things that don't make sense, but I kind of slip them under the radar. Does that make sense? So lots of things I didn't explain, but by the way I said it, it made it look like I explained it. Does that make sense? So for example, when you get down to 4, right? Yeah. How do you know there's going to be 2 black and 2 white? How do you know it's not like 3 black and 1 white? Yeah. Because if it's 3 black and 1 white, then Alice does that, and then Bob does something, and then Alice does it again, and Alice wins, right? Or if they're all blacks, yeah.
Yeah.
Then it doesn't. Then Alice loses, right? Because you can't stack the blacks with each other, right? So how do we know there's 2 blacks and 2 whites? Yeah. I kind of just said there was. Yeah. I didn't explain why. Yeah. And so that's kind of your job to pick up on. Does that make sense? Because actually, if you think about it, for a teacher who's not very serious about teaching you stuff, right? It's actually easier to just move along and not get questions, right? Because if I don't know why, and I don't want people to ask me why, right? And then I would just get over it, and then no one understands anything,
Yeah.
But what you're meant to do is, well, I'm meant to know why, and you're meant to figure out that I didn't tell you why, right? And then you ask, and then I tell you why. See? That would be a more ideal interaction. And then you get better at this when you get older, okay? Because when you're young, you tend to just trust everyone, okay? When you get older, you start realizing, oh, there's some issues. I don't have to trust people. I can actually see for myself what the answer is. You know what I'm saying? Okay, so why is there the same amount of blacks and whites? It's actually kind of a nice answer, okay? So at the beginning, okay, there's 50 whites and there's 50 blacks, right? That makes sense? So in particular, there's 50 white tops, yeah? And there's 50 black bottoms, okay? Alright? Now every move you do, you have to stack basically either a white top underneath a black bottom, yeah? Or you need to put a black top underneath a white bottom, yeah? Okay. So let's just care about white tops, yeah? White tops. Yeah, I should mention this solution is actually a student of mine called Celinski. Okay. So white tops, black bottoms, yeah? Okay. So let's think about how white tops and black bottoms change, yeah? The counts, if we're counting them, yeah? Every time we make a move, okay, like, the only way a white top stops being counted, right, is if something goes on top of it, yeah? Covers it up, right? Okay. But what can you cover it up with? Well, it has to be the bottom of something which is black, right? So that means what happens is the total number of white tops decreases by 1, right? And the total number of black bottoms also decrease by 1, because now it's no longer on the bottom, yeah? That makes sense? So that means every time you move, it either stays the same, the white tops and the black bottoms, the number, or they both decrease by 1, yeah? And so if they were the same at the start, they're going to stay the same afterwards. That makes sense?
Yeah.
Okay, so that means if there is something with a white top, yeah, there has to also be something with a black bottom, yeah? Okay, and since there's 4 things, right? There's 4 things. There's going to have to be 2 of them of the same color, yeah?
Yeah.
Right? There's only 2 colors, yeah? So if they were both white tops, then the other 2 have to be black bottoms, because it has to be the same number of white tops as black bottoms. That makes sense? Yeah, so can you see this is why people probably don't want to explain this. First of all, it's too hard for people to even know why it happens. And also, it takes a lot of effort to explain something that you don't think people are going to understand anyway. Yeah? Okay. So every white top has to have a black bottom. So that's why if there's 2 white tops, there's 2 black bottoms. And that's why when there's 4 things, there's 2 of each. Okay? Alright. Okay, so the next one's going to be a bit harder. But this one really can tell you what level you're at if you can try and solve this one. So this question.
This is a multiple answer.
No. It's actually multiple questions.
What?
Like, if there's 100 doors, and like each time you open a door, it's 1/10. How do you do it?
Huh?
Yeah.
Just let me give you an example, okay?
Yeah.
So let me just give you a bit of a head start with this, but you're meant to try to understand this yourself. But this is a bit harder. But the one thing that's good about this question is you can understand basically what it's asking, right? Everyone knows what a door and a key is, yeah? Most questions which are hard, they kind of eliminate your by telling you things which you don't know about. But everyone knows about doors and keys. So suppose I have like door 1, door 2, and door 3, okay? And I have key 1, key 2, and key 3. Yeah? Okay.
It says a door and these are keys.
Yeah, can you focus on this? We don't care about what you know, and we don't want you seeking attention. Understand? We want you to focus on this and learn something. Because at this stage, you pretty much know nothing. You understand? Okay. So we have 1, 2, 3 with 1, 2, 3, yeah? Okay. We don't know which key goes with which door, right? But we do know, like, key number 1 has to go into door number 1 or 2. Yeah? Like, it can't go, like, to a further away than the one that's next to it. Okay? So, for example, let's just say door number 1 goes to door number 2. Yeah? Okay, let's just say key number 2 goes to door number 1. Yeah? And then key number 3 goes to door number 3. Yeah? Okay. If that's the case, okay, let us do some tests. So if I do the test, okay, what can I test? I didn't know this. That's what it is, but I didn't know it, yeah? So first I can try and test. Let's do some obvious tests. I can do door 1 with key 1. Key 1 with door 1, yeah? Yeah? And then it tells me, oh, it fails, yeah? Okay. That makes sense? Okay, well, if the test fails, right? And I know that this key has to open one of these doors, then I know it actually has to open door 2, right? Yeah? So I actually know that it has to open door 2. That makes sense? Okay. And can you see that I also know that key 2 has to open door 1?
That means 3 has to go to 3 because 1 is in 2. It can't be on 1. So 3 has to go.
Yeah, so can you see here? I know 1 has to go to 2 because 1 has to go to either 1 or 2, right? So then this has to go to 2, yeah? And then since there's only 1 door and 1 key left, 3 has to go there, yeah?
Yeah.
So can you see I figured out all 3 of these keys and doors, right? With just 1 attempt. Yeah? I just had to try 1 with 1 and I figured out all of this, yeah? That makes sense? Okay, but I got pretty lucky, right? Because I don't actually know what it was going to be like that, yeah? It could have been like this. It could have been 1 goes with 1, yeah? Yeah, and then it could be like 2 goes with 3, and 3 goes with 2, yeah? So, it could have actually been like this, okay? Use your eyes. Look at that. Just stare at that and don't stare anywhere else, okay? And then use your ears and listen, okay? Use 100% of your attention on this. Got it? Okay, so it could have been like that, right? Now if I do the same test, it actually works the first time, yeah? So if I put the key in the door, it actually fits. So now I try 1 with 1. Okay? And it works, yeah? That tells me that this actually is 1 goes to 1, right? Yeah?
And then
But now I don't know anything about this now, right?
Mm.
That makes sense? Because 2 could go with 3, or 2 could go with 2, right? So now I've used 1 attempt, yeah? But I haven't figured out where the keys go, yeah? And because this is a possibility, okay, it means 1 attempt is not enough to figure out 3 doors and 3 keys. That makes sense? Okay, but can you see 2 attempts is enough? Because 2 attempts, all I have to do is I have to just check. For example, I can check this, right? And if it works, then I know it's this, yeah? And if it doesn't work, I know it's the other one, yeah? So I can figure out 3 doors and 3 keys with 2 attempts. Alright? And the question is,
100 doors.
can I do 100 doors and 100 keys in 99 attempts? Can I do it in 75 or can I do it in 74?
do 3 doors.
So 3 doors, I can do it in basically exactly 2 attempts, yeah? Because so I can't do it in 1 attempt, yeah? Okay. But I can do it in 2 attempts. Okay? So 2 is like the minimum number of attempts, yeah? And in some sense, we want to figure out what the minimum number of attempts is for 100 doors. Okay? Oh yeah, so someone said the number one. Yeah, the one only has 2 options and so does 100. Yes, indeed.
It's not enough.
Oh, how long are you gonna do? Huh?
75.
Okay, there was a suggestion. Let's explore the suggestion. Okay. So the suggestion is to put. Where's my mouse? Okay, the suggestion is to put key 1 into door 1 first. Yeah. Yeah. So if key 1. So the suggestion was to try key 1 and door 1 first. Yeah. Like that. And then try key 100 with door 100. Yeah. Yeah, I don't know. If you're thinking about this long enough, you realize there's actually a symmetry between the doors and the keys. Yeah. So there's actually no difference between trying a key in a door and trying the door on the key. Yeah. Alright, so okay, so if you try door 1 with 1, yeah, it could just fit, yeah, right? It could fit, and they just go together, right? Or 1 could go with 2, okay, and so it doesn't fit, but doesn't fit means you know that 1. Doesn't fit means you know that 1 goes with 2, yeah.
Doesn't mean 2 goes to 3.
Yeah.
2 goes to 4. 4 goes to 5.
No, so okay, so let's see exactly what that means. So can you see that this means that this 1 goes with this 2, yeah? Yeah. Yeah, so I guess if you think about it, right, you don't actually need to, so at the moment, like, we don't actually need to jump ahead to test 100 with 100, yeah? There's actually a lot to be learned from just testing 1 with 1. And so one thing I want to emphasize is you're allowed to do your tests based on the results of the previous tests. That makes sense? So like, I don't need to tell you which keys to test with which houses until at the very start. I only have to say the first one without knowing anything, but I can do the second one based on what I got for the first one. That makes sense? Okay. Now, if I got a success, then I know 1 goes with 1, yeah? Yeah. And if I got a failure, I actually know the result of 2 keys, yeah? Okay. So that actually means, if I can figure out 2 keys with 1 test, then I only need 50 tests, right? Yeah. And if I can figure out 1 key with 1 test, then I need at most 100 tests. That makes sense? Yeah.
What if you get
Yeah.
like attempts, like 10 attempts, and you get them correct,
Yeah.
and the other ones are on failure, so that means you get 2.
Yeah.
So 10 plus.
Okay, so I want to interrupt you for a second because you had this idea just before and you didn't finish it, okay? So you had this very good idea. You said, well, if we have 1 with 1 and 1 with 2 and 1 with 2, what do we know about the others, right? So you said, does 3 go with 4 and stuff like that, yeah? Okay. And what do we know about the others, okay? So if you think about it, we absolutely know nothing about the others, right? That makes sense?
Yeah.
So what actually happens is, in this case, it's as if we only had 19. So the question is with 100 things, right? So So what we do once we know the first two go together, we actually just get the question back again, but with 99 things. That makes sense? So we know as much about the 100 thing as we know about the 99 things. Yeah? To start the problem. Yeah? And here, the only difference is it's 98. Does that make sense? Yeah.
Hello?
Okay. Oh, hey, Aiden, can you hear me?
Yeah.
Okay, so we're working on this problem. Can you see the problem?
Yeah.
Alright, I'll give you a link if you want to rewind some of it.
Okay.
But yeah, but stay on Zoom.
Yeah.
Okay, so... Okay, does that make sense? So I think Nell said something about domino effect, so you're kind of like removing a domino, or they're removing two dominoes from this whole long chain of numbers. Does that make sense? Yeah. So can you see if we keep doing this? Okay, so can you see if we get this first result, if we get this result where we get 1 goes with 2 and 2 goes with 1, yeah? Yeah? If we get that result, so that means we know 2 keys with 1 attempt, right? Yeah? So, and then we have 98 keys left, right? Can you see, if we can figure out all 98 keys with 98 attempts, then we figure out all of them in 99 attempts. Right? Because there's 98 here and there's 1 over here, right? So 98 plus 1 is 99. That makes sense? Okay. So can you see how we can figure out all 98 of these with 98 attempts? Yeah, so can you see with the 98, right? You can just keep going. You can just keep testing the first one with the first one, yeah? Okay. Okay, so if we just kept doing this, matching the first one with the first one, right? And you see, I'll eventually get all of these with 98 attempts. Because every time I figure out one of them, right? But sometimes I figure out 2 of them, yeah? But figuring out 2 of them is just better than figuring out 1 of them. It's not worse, right? So even if I just figure out 1 of them, I would still be able to figure them all out with 98 attempts. Does that make sense?
Yeah.
So I just do 1 with 1, yeah? And if it fits, then I work it out. If it doesn't fit, I work out 2. That's even better, right? That's even quicker, yeah? So, but at worst, I can just do 1 at a time until I get all 98.
So it can basically be as many as.
Yeah. Okay. Okay, but what about if but that's because I have an advantage because I started off with 1, because I saved an attempt here, right? I saved an attempt here. I had an advantage. So, when I do this, I can just be sure I'll get it because I know I can get 1 for 1 here, right? At least, okay. But here I haven't got an advantage. I just got 1 for 1, right? Yeah. And I might never get an advantage. I might just get 1 for 1 the whole way, right? Okay. But But look what happens, okay? I take 1 and I go with 1, yeah? I go 1 and I get 1, yeah? If ever I have if ever I get 2, then I have this advantage and I can finish it off like this, yeah? So I can assume that I never get 2. I always get 1 and 1, yeah? Okay, so I keep going, yeah? 1 and 1, yeah? And I keep cutting this down further and further, okay? That makes sense? But what happens at the very end? If I keep doing this, what happens? If I just keep taking the first key and the first door and matching them up, yeah? What happens? So I'll give you 4 minutes to try to figure out what happens here, okay? I'll give you a couple of minutes to try and see exactly what happens. So the answer might surprise you a little bit. What do you guys think? Okay, so if we look at the very end, okay, so the thing is, you got to be careful because it looks like it's happening. The same thing's happening the whole way, right? But what happens when you get to the very end? Actually, something different happens. So what happens at the very end? Because you keep cutting, right? But at the very end, okay, there's 2 keys, right? There's the 99th key, and then there's the 100th key, right? Yeah. 收的。你上来还是我送他下来？
结束了吗？
你上来。
可以，我上来接他，没关系，我上来接他。
好，
拜拜。
Yeah, okay, so we finish this, and Gabriel can go, okay? But so look, if you look at this, when it gets to the very end, okay, when you figure out 99 goes with 99, yeah? Yeah? Can you see that you don't have to waste an attempt to figure out 100 goes with 100? Yeah? Because you already know that 100 goes with 100 because there are only 2 left, right? Does that make sense? Okay. So if you know that 100 goes with 100, okay, then actually this whole thing actually only takes 99 attempts. You see? Does that make sense? Okay, so maybe there's maybe a nicer way to show this, but it's a little bit more complicated. I can try and show you before Gabriel leaves. So I can try and do something like this. 1, 2, 3, 4. Okay. And I can test 4 with 4. Okay. Okay, I can test 4 with 4, okay? Right? So if 4 goes with 4 and they actually go together, yeah? Can you see? I basically cut the problem into 2 parts. So I got a problem that has like 96 things in it, yeah? And I have a problem that has 3 things in it. Does that make sense?
Yeah.
Okay. Okay, so that's if 4 goes with 4, okay? But 4 might not go with 4. Shall I open the door? So 4 could go... 马上结束，就讲完这个就结束了啊。Okay, so if 4 goes with 4, you can cut it into 3 and 96, yeah? Okay. But if 4 doesn't go with 4, okay, you can test if 4 goes with 5, okay? Right? Okay, and the thing is, if 4 has to go with 5, 4, or 3, right? Okay, so if 4 goes with 5, okay, then you're good. But if 4 doesn't go with 5, then it goes with 3. Yeah? Okay. But if you look at 4 and 3, if 4 goes with 3, right? So 4 goes with 3, yeah. Yeah? So let's just look at these 2 cases. So if 4 goes with 3, 4 goes with 5 is a very similar case. Okay, so if 4 goes with 3, okay, you actually know that you actually know that 3 has to go with 4 also. Okay? The 3 has to also go with 4. And the reason is because you only have 3 numbers, you only have 2 numbers over here, and there's 3 numbers over here, right? So 3 numbers can't go with 2 numbers. Okay? So it has to go, the 3 has, and 3 is the only one that could go with the 4, so 3 ends up with the 4. Yeah? Okay. If it goes with the 5, for the same reason, the 4 has to also go with the 5. Okay? So basically what I'm saying is it either cuts it up into 1, 2, plus like 5 to 100. Yeah? Okay. Or it cuts it up into 1, 2, 3. Yeah? And then 4 goes to 100, yeah? And the point is, this is a little bit nicer because it's easier to imagine that you can get, so from 5 to 100, you can get all of this with 1 attempt each, right? Okay? But you can save an attempt when you're doing 1 and 2, yeah? So that means you can still get it in 99 attempts here, right? Okay, and then here 1, 2, 3. We actually did 1, 2, 3 before, so you can actually get 1, 2, 3 with 2 attempts. Remember? So if you save an attempt here, okay, and you can get 1 attempt per thing here, and that'll get you 99 as well. Okay. All right. Okay, so we farewell Gabriel, but we'll go for part B and part C in a little bit. So have a think about part B and part C while you're waiting. Okay.
OK 谢谢了。我把下那我把下周的行李对，我就不用找我。OK， 好，没事。他今天上的怎么样？专注力今天是会差一些，然后蛮累的。今天起的比较早。怎么样？今天就比上次难度比较难还是？上次是从更简单的开始变得更难，但这里变成就是把压缩在这种 steep OK 没那么 steep OK 更 steep OK 但是没那么高 OK 那这样就今天怎么样？还 OK 吗？有懂吗？你不懂的话，你要问 Michael 哦。希望每个系统要问一个问题。OK 这你问他一个问题。要他问哦，让他问，然后他问的问题都是有就是 constructive 的问题。OK 是，其实不 constructive 开始瞎问我有。今天另一个男还没来。哦，对他这个星期有方式。哦 OK 好吧 ，Gabriel，Let's go， 你要打控图。走吧，你们跟他们拜拜啊。拜拜。我们看周日见了，看周日有 OK 的话，希望我们，或者就来跑一跑，试试看干什么。我可能9点。OK， 你们周日有 games， 周日几点的 game？ 我刚刚查错了，我现在，我可能早点。哦，可以早点。我把时间。OK， 没事。OK， 到时候看。OK， 好，那先这样。OK， 好，拜拜。拜拜。
I'm gonna do it with another pencil. I'm gonna pop it to the other side.
Okay, guys. Alright, so the 75 one's going to be pretty tough. So I want you guys to think about it a bit more before we start talking about it. But if you're kind of paying attention, there were a few hints already, but they're very subtle. So I want to be able to explain the last two by the end. But this question, like, if you can solve this question, please come to A level because this is the question that really, like, it's the 4th question in the junior, so it's right in the middle of the paper. And it's the first question in the senior, so it's right at the beginning of the senior for year 11s and 12s. And if you can solve this question, like, that's already very, very good for this competition. And even if you can't, like, I think you can probably enjoy some of the earlier questions. So they're really good questions. Okay, so we're getting some pretty good ideas. Let's give people a bit more time to think about it before we start talking. So how can we do it in 75 attempts? If you're on the stream, you can like, and subscribe. That'd be great. Hmm.
Oh, because I want to make more hands. I want to make more hands. Do you know where the gloves are?
I'm busy. You're not in class anymore? Is that what you're saying? So the exam you do is you get 5 hours to solve 3 problems, and if this is one of the ones you're attempting, it could be like if you attempt like the first 3 or first 1, 2, 4 or something, you could literally have like 3 hours for one question. Yeah. But obviously, if this was like if you're attempting like 4, 5, 6 or 4, 6, 7, you probably only have like half an hour, 1 hour for this. You know. But yeah, and in senior, obviously, no matter which combination you'd attempted, you'd get less time for question 1. Okay, so have you had a good think about this? So it was suggested in the chat that we cut things up, okay? And cutting things up is actually a pretty good idea. Alright, good question. So look at this, okay? So I have to explain. So if I have, so remember I showed you like if I had 5, right? Yeah. If 5 goes with 6, yeah. So if door 5 goes with key 6, yeah, then door 6 must also go with key 5. Does that make sense? So my claim is if a key doesn't go into the same number, whatever number it goes to, that door has to go to that number key as well. That's what I'm saying. So if key n goes to door n plus 1, then key n plus 1 has to go to door n as well. Yeah, so if 5 goes with 6, then 6 has to go with 5 also. That makes sense? If key 6 opens door 5, then key 5 has to open door 6. Okay, so you understand the statement, yeah?
Yeah.
Okay, but you know why it's true? Hmm?
No.
Okay, so the reason it's true is, okay, so imagine like, so we got 5 goes with 6, yeah?
Yeah.
Okay. So what's happened is this has created an imbalance, okay? Because now we have here we have 5 things here, right? Yeah? But here there's only 4 things, okay? That makes sense?
Yeah.
So 5 things is too many for 4 things. That makes sense? Only 4 things need to go with these 4 things, yeah? So that means the 5th thing has to go away, right? Somewhere else. Okay? But there's only one thing that can actually go away, it's the 5 here. That's the only thing that can go away, and it can only go away to 6. Does that make sense? So if 5 goes with 6, then 6 goes with 5 the other way as well.
Yeah.
Okay? And actually the converse is also true. So because the converse is basically the same as the statement, then you also get the contrapositive. So you get the converse. So here, or you get like the inverse. So if 5 doesn't go with 6, yeah, then you also know that 6 doesn't go with 5. Okay. Because obviously if 6 goes with 5, then 5 has to go with 6.
Yeah.
Okay? So that means you also know if it doesn't go, it actually doesn't go at all. Okay? Okay, so that actually tells you a lot. So what that tells you, okay, is when you do one of these tests, okay, when you do a test for 5 going with 6, or something that doesn't just go with the same number, okay, that test will always cut the things into halves, okay? How that works, I'll have to explain a bit later at the moment. So, let me try to explain that. So, let me give you an example, okay? So you have 1, 2, 3, 4, 5. Yeah. Okay, you're not really listening, so I don't even know if I should bother explaining. But the point is, if I test 4 and 5, okay,
Yeah.
if it does work, right?
Yeah.
So if it does work, then what I essentially have is I get this, and I know both this information, and I cut it into 3 and 95, okay? So I cut it into this block and this block. Okay. So that if it does work, I get these two and I cut into these blocks, okay? If it doesn't work, okay?
Well, that's what you meant.
Yeah. So if it doesn't work, then I get 4 doesn't go with 5, and 5 doesn't go with 6, okay? And it cuts it into these two blocks. Because if 4 doesn't go with 5, then it might as well be the edge, right? Because it can't go any further past the edge. And if 5 doesn't go with 4, it may as well be the leftmost edge of this block, okay? So I have a shorter block here of 3, and I have a block of 96 here. Okay. Okay, but the difference with this cut, okay, is that I used an attempt on the cut, but I didn't get to know any of the key to door. I didn't find out which key went to which door. Okay. So the only difference between failing and succeeding is that we still get the cuts, okay, but here we don't actually get to know one of the keys. Yeah. So we're actually one attempt behind. Okay. Yeah. Okay, so we're almost there. But your brain seems very fried. But you should keep trying to listen. Okay. So what can we do? Okay, so what can we do? We can use that idea to try to make some cuts, okay?
Yeah.
So what is 75, right? 75 is 3/4 of 100. Yeah? So if I can figure out 4 things in 3 attempts, yeah? Yeah? So if I can figure out 4 things in 3 attempts, on average, then I can get 75. Right? So in some sense, I have to be able to... Yeah, but the thing is, if I just have 4 things, obviously I can figure it out in 3 attempts, because that's essentially just the 99, that's part A. How to save 1 attempt. Right? Okay, but what I want to do is I want to save attempt every 4. Yeah? But then I save 25 attempts, and then I can do it in 75 attempts. That makes sense? How do I guarantee it? Okay, let me show you. Okay, so... Okay, so I get 4 with 4, yeah? Yeah. So if 4 and 4 succeeds, okay, then can you see that just cuts off this block of 4, okay? And I know I can save an attempt with 1, 2, and 3, yeah? Yeah?
But what if it doesn't succeed?
Yeah, you gotta wait for that, yeah? I'm telling you, if it does succeed, this is what happens, yeah?
Yeah.
Yeah? So if it does succeed, then you're good, right?
Yeah.
Because you can just keep doing this and you win, right? Okay, what if it doesn't succeed, yeah? So what if it doesn't succeed? So if it doesn't succeed, you've used an attempt and you haven't gotten anything out of it, yeah? Okay. But then what you do is you test 4 with 5, okay? So then you test 4 with 5. Yeah? So if 4 and 5 does not succeed, yeah? Okay. Now what happens if they don't succeed? If they don't succeed... Alright, where's my mouse? I'll change this to green. So if it doesn't succeed, okay, right, then you know 4 has to go with 3, right? And if 4 goes with 3, then 3 has to go with 4. Yeah? Okay. And so for your 2 attempts that you did, you actually figured out 2 things. Yeah? But you've also cut off this from the rest. Yeah? Yeah? Because this the rest doesn't care about 3 and 4 anymore because 3 and 4 go with each other. Yeah? So you've cut that off, okay? And in this bit there's only 2 things here, right?
Yeah.
And you can figure both of them out with just 1 attempt. Yeah?
Yeah.
Because you can, so basically you can save an attempt, right?
Yeah.
Okay, so that means if 4 doesn't go with 5, then you can still get the first 4 in 3 attempts. Yeah? Okay. So the only other case left is if what happens if 4 goes with 5. Yeah?
Yeah.
Okay. So what happens if 4 goes with 5? So if 4 actually does go with 5, okay, so 4 goes with 5, yeah, then we know that 5 goes with 4, yeah? Yes? So we still have gotten to know 2 things with 2 attempts, yeah? Okay. And we've also cut off a block here. Does that make sense? So we've also cut off a block here, yeah? Yeah. And on this block we can save an attempt, yeah? Let's call this -1. We can save an attempt on this block. Do you know what I mean by save an attempt?
Yeah. -1.
No, it means I can figure out all 3 with 2 attempts. Okay. Okay, and then you have 6,
And if we keep doing it, then
7, 7, 8. 8. Okay, so here, so I just keep repeating this, right? So if I test 8 with 8, right, and it succeeds, then I get a block of 2 here, right, which I can save an attempt, yeah? Which means from 1 to 8, I've saved 2 attempts, yeah? And if 8 goes with 7 and 7 goes with 8, I also get this saving for free, yeah? So the only thing that I'm worried about is if 8 goes with 9, okay, and 9 goes with 8, yeah? Right? But can you see it just repeats what happens at the start, but with a block of 2 instead of a block of 3, okay? So I can keep doing this on and on, yeah? Then what I get is I get a block, I get 1 block of 3, and then I get lots and lots of blocks of 2s, yeah? And all the other things I've eliminated 1 thing for every attempt. So I'm neutral with attempts. I haven't saved or gained or lost attempts. Yeah? But on every one of these blocks, okay, I get to save an attempt.
Yeah.
Because I can figure out 3 in 2 attempts, and I can figure out 2 with 1 attempt. Yeah?
Yeah.
So however many blocks there are is how many attempts I save. Okay? Okay, so then the question becomes, how many blocks are there? Okay? So maybe you guys can tell me how many blocks are there?
it's a 8. Wait, each 8 is 2.
Yeah, every 8 there's 2 blocks, right?
Yes. Then just divide 8 by 100. That will be a roommate. And 4, 5 blocks.
It's 4.5 blocks.
Yeah.
Yeah, but you don't have to think about it as 8 there's 2. You could think every 4 there's 1, right?
Yeah.
Yeah? Because if every 4 there's 1, 100 divides by 4. 100 is divisible by 4. Yeah?
13. 13.
What? 100 divided by 4 is not 13.
Oh, wait, no.
Yeah, there's 25 blocks, yeah?
5.
Yeah, because every 4 there's a block, yeah? That's exactly what we wanted, right? Every 4 we save a attempt,
Oh, yeah,
right?
it's 25. Oh, yeah, that's exactly.
Yeah.
Oh,
So this idea works in exactly 75 attempts.
how do we save one more time to get some?
Yeah. Okay, so I have a question. So this is a motivating question here. So if so you might wonder, like, why is the first block 3? Okay. When the others are all 2, yeah? Does that make sense? Like, here, taking the 8th number is not actually the 8th number in the block, right? So this is actually the 3rd number in the block, yeah? Whereas at the start, we took the 4th number in the block. So the question is, like, why didn't we take the 3rd number to begin with if you were just taking the 3rd number here? Okay. So I'll give you a little bit of time to think about that. And I'll probably spend a lot of the time trying to explain how the other thing works. So Aiden, Blake, Lucas, you guys have any questions?
No.
No.
Okay, does it make sense so far? Are you still thinking about part C though? So remember, try to ask a question if you can at every segment. Yeah. Yeah, I guess you don't get quite this pattern 8-9 pattern at the 100th door, right? It's just 100 gets the 100 or one less, but you still save an attempt, yeah. Yeah, so I don't think that. Yeah, so if you look at the very last block, it'll look like this, okay? It'll look like 90. So it'll be 100 at the end. The last multiple of 4 is 96. Okay, and then we get that 96 goes with 97. Which means 97 goes with 96. Okay, and then we get 98. Okay, 99. And then 100, right? Yeah.
Yeah.
So I think so that this case actually is a little bit different because there's no 101 anymore, okay?
Yeah.
So I think if we were to fail the 100 goes to 100 here, then I mean so failing the 100 goes with 100 here is basically the same as succeeding, yeah? Because well, in terms of the information, because you get to know where 100 goes, but if you succeed, you don't know where 99 goes, okay? So I think the difference here is you have to assume that 100 succeeds here, okay? Does that make sense? So if 100 succeeds, so you can't assume it fails. So now it succeeds, you know 100 goes with 100, right?
Yeah.
And then you actually get a block here. So you can't get one for free by saying 100 fails. Okay, so here it's still only 75 attempts, okay? So it's not 74 yet. Okay? So at the very end the 100 succeeds with 100, so you still don't know if 98 goes with itself or 90 or goes with 99. Okay? So the method here gets you 75 attempts, okay? And the question is, can you do it with 74 attempts? I'll give you another 6-minute think, and then I'll start explaining some of the ideas. I'll give you a few more minutes, okay? Alright, just give me 1 sec. It's like 1 more minute, guys. Alright, so what do you guys think? Is it possible to do or not? Okay, so let me show you this thing, okay? So what does it even mean to be able to do it in 74 attempts, right? What does it even mean to be able to do it in 74 attempts? Okay, so it means that you can somehow do better than getting 3 attempts for 4 things, right? Okay. So you have to be able to get better than 3 attempts for 4 things on average somewhere, right? Okay. And I mean, if it doesn't work, okay, how would you prove it doesn't work? You know what I mean? Yeah, so one way of proving it doesn't work is, well, so this is the most naive way, but it could be the best way here, is to try all the ways that you could actually try to make it work, yeah? And if you can't make it work with all the ways, then it cannot be done, right? Whereas you got to be careful here, because a lot of people, they try to make it work with only some of the ways, and those are the ways they can think of, right? And then they can't do it with that, and then they say it can't be done. But we have to make sure it's just not, there aren't any ways that we haven't thought about, okay? Okay, so let me give you an idea, okay? So suppose, so there's actually a lot of things that are actually pretty difficult, because you can't just put all the attempts at the start, because each attempt could depend on the result of that attempt, right? The previous attempt. Okay, so be careful when you use the word we have to, okay? You don't necessarily have to, okay? But yeah, in some sense, in some sense we do have to logically, but I guess it doesn't have to be as necessarily direct, okay? But we may have a direct way as well. So if you look at all these numbers, okay, like, so what happens is, if you can get 74 attempts, right? Then at the end of 74 attempts, you have to know exactly what door goes to which key, right? If there's still something you don't know, then you fail, right? Okay. So one of the problems is, if we have 74 attempts, it might also matter what order the attempts come in, yeah? That makes sense? It might make a difference if we tried the one on the left first, than if we tried the one on the right first, yeah? Okay. But the order doesn't matter as much as we think it might, because what happens over on the left doesn't really affect what happens on the right, yeah?
It's kind of like symmetrical.
Okay, what you're saying doesn't make sense relative to what I'm saying. So this is one of those things where you can think it, but don't say it, yeah? Okay, so let's consider maybe the leftmost attempt, yeah? The leftmost attempt, yeah? Yeah. And in some sense, we can also make some assumptions about the result of the attempt, just because we want the attempt to guarantee success, so we can actually make the results kind of unfavorable to make the success harder to get. Yeah. So imagine if our leftmost attempt was this. Yeah. Like that was our leftmost attempt. So if that was our leftmost attempt, then we can essentially delete it. So we can basically assume 1 does go with 1 and assume it succeeds. Okay. And that's equivalent just to doing the problem for 99 things. Okay. So you're trying to save 26 attempts. But you have less things to work with now. Okay. Does that make sense? So, you know, you could get lucky that 1 goes with 2, and you already save an attempt, and you have 98 things. Okay. But you could also get unlucky, and you save no attempts, but you don't lose any attempts, and you're down to 99 things. Yeah. Okay. Yeah. So you're not owed an understanding. Do you understand? You have to make, like, you have to earn the understanding. Yeah. So there's a lot of preparation that goes into your mind that makes you understand stuff. Okay, so in some sense we can assume that 1 with 1 is not the first test that's leftmost. Okay? Because if you do that as your leftmost attempt, in some sense you wasted it. Because you don't have any chance to save any attempts. You just made the problem harder. Yeah? That makes sense? You have 99 things now. And you have to do it in 73 attempts. Okay? Alright. Okay, so there's no point making the first one vertical. Okay? Because no matter what the other attempts are, and no matter what order you did them, the result will be the result on the 99 objects on the right. Okay? Okay, so if 1 doesn't go with 1, then maybe 1 could go with 2, yeah? That could be our leftmost attempt, yeah? But the thing we realized before is that testing 1 with 2 is the same as testing 1 with 1, okay? Because you get the same information, right? So again, we can assume 1 just goes with 1, and we're down to just the 99 case with no attempt saved. Alright? Okay. Now, so that means you shouldn't test 1 with anything at the leftmost, okay? I'm not even saying first, yeah, because the attempt could be the 50th attempt, you know what I mean? But the point I'm making is that it doesn't matter what order you do that attempt, it sort of reveals the same information, okay? Okay. So the leftmost attempt doesn't involve a 1, okay? So then it's either 2 goes with 2, 2 goes with 3, or it doesn't involve a 2, yeah? Okay, let's look at what happens if 2 goes with 2, yeah?
Yeah.
Okay, if 2 goes with 2, and it works, yeah, so it succeeds, then you also know 1 goes with 1, yeah? So that saves you an attempt, right? So that'll make it easier for you. But we don't want it to make it easier for us. We want to do it. We want to guarantee it, right?
Yeah.
So we can assume that 2 doesn't go with 2. Yeah? Okay. So if we know that 2 doesn't go with 2, we still don't know, but we still don't know if 2 goes with 1 or 2 goes with 3, right? Does that make sense? Okay. So what happens if 2 goes with 3, yeah? So what happens, then you could test, then you could do another test, yeah? Okay. But the thing is, because this is the leftmost test, okay, right? And the fact that you still don't know where 1 goes, it kind of puts pressure on this test, the next test, to actually tell you where 1 goes. Because you can't just have a whole bunch of blanks. Like, you can't just have the next test happen over here, okay? Because if the next test happens over here, then there's too many combinations of things this could be. And so your tests can't work, right? So there has to be another test to sort of help you determine where 1 goes. Okay? So what does that test might look like? So if the test, so we do 2 and 2. If the test, for example, is 2 and 3, yeah? If that's the test, yeah? Okay? So that will do what we want, in the sense it'll determine what happens to 1, yeah? Okay, so for example, 2 could go with 3, and then 3 goes with 2, and then 1 has to go with 1, yeah? That makes sense?
Yeah.
Okay, in which case, you save an attempt on the first 3, actually, yeah? Okay, so you probably won't get that lucky, okay? So, what probably will happen, yeah? So in some sense, this is the worst thing that could happen, the worst case scenario, which I don't like using the word because people keep using it incorrectly in the exams I mark. Okay, so more likely than not, 3 doesn't go with 2, right? Or at least to keep it difficult for us, 3 won't go with 2, and so 1 will go with 2, yeah? So if 1 goes with 2, then 2 goes with 1, yeah? Okay? And notice, now if we just look at all the information we actually have no information at all to the right of this line, okay? We literally use 2 attempts to find out 2 things, and we know nothing about the right side. Yeah? Does that make sense? Okay, so we literally know nothing about the right side, and we know 2 things with 2 attempts. This is exactly the same as just shaving 1 off the end and 1 off the end. We haven't gained anything, and we have just 98 objects left, and we need to save still another 26 attempts, right? So with 98 objects, we need to do it in 72 attempts now, okay? Yeah, so there's actually no point to test 2 with 3 if we test 2 with 2, okay, for that reason. Okay. So then the only other option we have, okay, so now we have to use 3 now, okay? So if we don't do 2 with 3, what if we do 3 with 4, yeah? Okay, so if 3 doesn't go with 4, yeah? Okay. Then 3 could go with 2, or 3 could go with 3, yeah? Right? So that means if we do that and we don't get it going with 3, then there's 2 possible ways that the first 3 things could be. Yeah, because essentially if it doesn't go with 4, it just cuts it off there. That's all. That's what that means. Okay, and we don't know what happens over here. Okay, but we can know what happens after one more attempt, right? Because we know what happens with 2 and 1. But it doesn't matter what happens. The point is, we only end up knowing 3 things with 3 attempts. Yeah? So we don't save any attempts. Okay? So there's actually no point for the 3 to go with the 4. Okay? I encourage people to say something if you're not understanding, but okay, so the 3, there's no point for the 3 to go with the 4. And if we don't do 3 at all, then there are going to be too many possibilities here. Because if we just do 4 with 4, then it could succeed and cut off here, and then we don't know what this is. Does that make sense? Alright, so wait, hold on. We're 4. Sorry, if we go 4 with here, it could just be a no. Okay, and then we know 4 could go with 5. 4 could go with 3. And we're going to have trouble figuring out these 4. So at the moment, it could be 1 goes with 2, and 2 goes with 1, or 2 goes with 3, and 3 goes with 2. Right? But just because 4 doesn't go with 4, it doesn't mean that 1 goes with 2 will determine 3 goes with 3. Okay, so okay, the point I'm trying to make is if you don't test with 3, I think you'll be too far away. Okay, so you'll be too far away to be able to determine it. So yeah, so I'm defining these 2 tests to be the leftmost tests, right? So if it doesn't involve 3, then you can't test again over here, and if it doesn't determine it, then you failed, right? Okay, so you should test with 3, okay? Because you can't get all 3 with just that 1 attempt in the middle there, okay? Okay, so then the only test you can do with 3 is 3 goes with 3, right? Okay, because we considered what happens if you do 3 goes with 4. Okay, and if you notice, this is exactly the answer to my question: why not start with 2 or 3? Why start with 4? This is exactly answering that, because I'm actually telling you what happens if we start with 2 or 3. Yeah. So I'm saying that if you're starting with 2 or 3, you're probably going to get unlucky and not save any attempts. Okay. Okay, so if you go 2 with 2 and 3 with 3, okay. So at the moment, you still don't know if 2 goes with 3 or 2 goes with 1. Okay. So this doesn't determine the first 3. Okay. And again, if you take 3 with 4, then we do know that 3. So if we do take 3 with 4, then we know either 3 goes with 4 and 4 goes with 3, or 3 goes with 2 and 2 goes with 3. Right? Yeah. Yeah, so when we take 3 with 3, we can assume that 3 doesn't go with 3, okay? Because if 3 does go with 3, then you've basically worked out the first 3 in 2 attempts. Yeah? So you can assume 3 doesn't go with 3, okay? But the possibilities are 3 goes with 4 or 3 goes with 2, okay? So if you test out with 4, okay, then you'll know 3 goes with 4, for example, and then 1 has to go with 2, okay? So then you'll know 4 things in 3 attempts, yeah? Which is still just the bar. We haven't beaten the bar, yeah? Okay. Yeah, I guess no matter what happens here, we'll have already used 3 attempts. Okay? And we can't know more than 4 things.
Yeah.
Okay? So basically there's no point taking the 3 with the 4 after taking 3 with 3. Okay, so even in the other case, 2 goes with 3 and 3 goes with 2. And then 1 goes with 1. Okay. You don't know anything about that. So then you're really just doing the first 3 with 3 attempts. You see that? Yeah? And that's not what you want. Okay, so then there's no point doing 3 with 4. Okay. Okay, and can you see with the same reasoning as before? So the same reasoning as before, you can't just leave out 4. Otherwise it's going to be too far to determine the left things. So the leftmost thing has to have 4 going with 5 or 4 going with 4. Yeah? Yeah, so again, if 4 goes with 5 and it's a fail, then you're really just cutting it off at the first 4. Okay, and cutting it off at the first 4, you've already used 3 attempts. Does that make sense?
Yeah.
So you can't save an attempt at all on the first 4. Okay? So to have any hope of saving attempts, you really need this to happen. Okay? Yeah? And can you actually see this argument just kind of keeps going? You keep just doing vertical ones. Yeah?
Yeah.
Okay. And the problem with this is if you keep doing vertical ones and you keep failing, right?
Yeah.
You won't ever know which one it is. Like you don't know if 1 crosses with 2 or if 2 crosses with 3, yeah? So it could go like down and then cross, and just keep crossing. Or it could go like cross first. Oh wait, it can't go cross. It could go cross first and keep crossing, yeah? Okay. So you don't know where the crossing starts. And you only have 70 attempts. You don't have 100 attempts. So you're gonna have to stop it like halfway somewhere, right? Okay. So let's just imagine what happens more generally when you get to like a whole bunch of vertical lines, yeah? Let's say there's like 20 of them or something. Yeah? Okay, so at the moment you don't know which one is which, right? Okay, but once you test like this one here, okay, then you know it's either going to be this cross or this cross, okay? And then when you know it's this cross, all the crosses become determined, yeah? Okay, and then it kind of gets cut off either at the next one if it's a success, or it gets cut off here if it's a fail, okay? But the point is you've done all of that, okay? And you've only saved, like, you haven't saved any attempts, okay? You've possibly saved 1 attempt here if it's a success. That makes sense, okay? But it's been like 20 things, okay? So this gets even worse when you go beyond 4, okay? It doesn't get better. So what this proves is it proves your leftmost thing cannot be a 2, goes with 2. That can't be your leftmost attempt. Okay? Or at least it kind of explains why it can't be 2 goes with 2. Okay. So there's actually an exercise to actually write a proof of this, which is actually not going to be easy, but first you need to understand it. A proof is not the same as understanding something, okay? They can be different in different ways. Okay, so alright, so 2 should not go with 2 for you to have a chance, yeah? Okay. That makes sense? Okay, so what if your leftmost attempt still involved a 2, it was 2 with 3, yeah? Okay. Well, remember, if 2 goes with 3, we can just say that fails, okay? And if it fails, then it cuts it up in here, okay? And then it becomes, we need 1 attempt to resolve these 2 things, right? Which is a total of 2 attempts to get 2 things, right? So it hasn't helped us, okay? So there's no point having the leftmost attempt be 2 goes with 3, yeah?
Yeah.
Okay. I should speed this up a little bit. We only have like 5 minutes, but hopefully, see, the more you understand the start, the more I can speed up the second part, but the less you understand the start, the more it's kind of just like repeating the start. Okay, so now, if 3 goes with 3, okay, yeah, okay, so if 3 goes with 3, and that's your leftmost attempt, okay, yeah, can you kind of see you're already going to have a little bit of a problem, okay, because if that's your leftmost attempt, the problem that you're worried about is how am I going to determine what happens to the 1 and 2, yeah? That makes sense? So if 3 goes with 3 is your first attempt, okay, and it succeeds, okay, then you can save on 1 and 2, and then you actually save 1 in the first 3, okay? So you shouldn't assume it succeeds, okay? You may as well assume it fails, okay? So if 3 goes with 3 fails, then 3 either goes with 4 or 2, yeah? Okay, so if your next attempt is to show 3 goes with 4 or not, okay, so if that's your next attempt, then you may as well have it succeed, okay, because if it fails, then you know 3 goes with 2 and you get the first 3 in 2 attempts, okay, so you may as well have it succeed, and if it succeeds, it means you get 4 goes with 3 as well, okay, and you get 1 attempt for these 4, okay, and you get the first 4 in 3 attempts, yeah, which is good, yeah, because you want to save an attempt, you saved an attempt, yeah, but it's not good enough, okay, because you need to save more than 1 attempt every 4, right? If you only saved 1 attempt every 4, you only saved 25 attempts, okay, so it's good but not good enough, okay. So the next attempt shouldn't be to go with the 4, okay. Okay, but for example, if the next attempt didn't involve the 4, okay, then it'd be cut off here. Okay, let's just do this. So the next attempt could be 4 goes with 4, yeah? Okay. And notice these arguments are actually general, okay? So we're not actually far off the finish line in terms of solving, but we are a little bit far in terms of proof writing, okay? Okay, so 4 goes with 4. If that was your next attempt, like the next leftmost attempt, okay, if it were to succeed, then you'd be able to get the first 3 kind of cut off with 1 attempt, and you would know that you would get all 4 in just 2 attempts, okay, so you can assume it doesn't succeed, okay, and if it doesn't succeed, we don't know if it goes 3 4 and 1 2, okay, or it could go like it could go like 4 5 and 2, 3, and 1, 1. Yeah. Or it could go like 1. Yeah. We don't know how shifted the crosses are. Yeah. Okay. So okay, and obviously if the attempt didn't involve 4, okay, not only would we not know how shifted the crosses are at the moment, we'd never be able to know because these are too far away to help you determine it. Okay, so for example, if 5 goes with 5, and we don't know, we have 4 things and 1 attempt with 3 and 3. Okay, so we'd have to get the other 3 in just 1 attempt for it to be kind of have any to actually just be tied. It's not even good enough. Yeah. So actually, hold on. It'd be 5 numbers in 3 attempts. Yeah. So let me erase this thing to make it more clear. So if I'm doing like 5 with 5, yeah. So if I don't involve 4 at all, if I do 5 with 5, okay. Like I could get unlucky, and I don't know if 5 goes. So let's just say I do know 5 goes with 5. Okay. And then I have these 4, and I have 2 attempts already. Okay. So the question is, can I do all this in 1 attempt? Okay. So if I do 3 goes with 4 and 3 actually does go with 4, I get those 2, and then I know these 2 go with each other. Yeah. But the problem is they might not go with each other, and this goes with that. Okay, and then then you know these 2 go together. Alright, so if you can do this in 3 attempts, then we should probably not say that 5 goes with 5. Okay, so can you do this in 3 attempts? So that's 2 attempts there, and you have so if I, for example, did 4 with 4. Oh wait, no, I can't do 4 with 4. No, of course. Okay. No. Okay, if this was our leftmost attempt, then we don't have any more attempts, so that's just a fail. Yeah. Okay. So it's not about saving, it's that we can't do any more. Okay. So we're not allowed to put any more attempts here. Okay. So yeah. So the next attempt has to involve a 4. Okay. And so we end up with. So just bear with me. I'll finish in like 5 minutes, hopefully. And then so this has to be the next attempt for this to get anything. Okay. And you can kind of see it's starting to get the same thing that we did for 2. Okay. But it's going to be even a bit harder because we have 2 things here that we can't actually determine. Okay, so for the same reason, the next attempt shouldn't be a 5 with a 4. Okay, because if it was 5 with 4, for example, and it failed, okay, it would just be cutting it off at the first 4. And then we wouldn't know. Oh wait, hold on. If it failed, actually we'd know that 4 would go with 3, yeah? So if it failed, we know 4 goes with 3. 3 goes with 4, but then we don't know anything about whether 2 goes with each other or by themselves. Okay, so that's the problem. If it succeeded, 5 goes with 4, and then 3 would have to go with 2, and then 1 would go with 1. Yeah, so if it succeeded, it works, but if it fails, then we don't actually know what happens to 1 and 2. Okay, so that's a problem. Okay, so then, and again, if it doesn't involve 5 at all, it's going to be too far to help. And so it has to be kind of like this again, with these vertical lines. Okay. And obviously, at any time it kind of cuts it off without knowing anything, we can't determine it. Okay, and if it does cut it off with knowing something, well, we've saved only 2 attempts for like however many numbers we've got. Okay. Possibly not saving. Wait, if we can save 2 attempts. So what's the bar here? If we can save 2 attempts. So we want to save 1 attempt every 4. We want to save more than 2 attempts every 8. So if we can save the 2 attempts before we got to the eighth one, we might have a chance, right? But the 100 is not divisible by 7, so you might still have a problem. So let me just quickly investigate this thing. So if you, yeah, I think it's not that you save the 2 attempts. It's that if you decide what happens here, it could happen the wrong way. And if it happens the wrong way, then you just can't tell what happens here. Okay, so for example, if at this point here, you decide to do a different test, instead of going vertical, you go sideways, okay? If you go sideways and it succeeds, okay, then you get these x's like that, right? So then you don't know what happens to 1 and 2, okay? But if you do it that way and it fails, where's my mouse? So if you do it that way and fails, then you know it goes this way, right? Okay, and then you do know what happens with 2 and 1 and 2, okay? But there's nothing that says it should fail rather than succeed. So your example could actually succeed, and then your test doesn't work because you can't determine what happens to 1 and 2, okay? So you don't actually save, it's not that you save 2 things with too many things, it's actually that you can't determine what happens to 1 and 2 because you're too far off from the end, yeah? Okay, and then I think I'm going to end it very soon, but the basic idea is the next thing to consider is 4 goes with 4, but you basically know what happens with 4 goes with 4 because that was the strategy that got us the saving of 1 every 4 in the first place, right? So when 4 goes with 4, we had that it cut it off and it managed to get 3 out of 4, but it didn't do any better, right? So I think this argument should at least convince you that it's not possible to get it done in 74 attempts. Okay? Yeah. But whether or not it can actually be done in 74 attempts, that's where the proof comes in. So once you write the proof, then you'll be like absolutely certain that you can't do it in 74 attempts. Okay? Alright, so I hope you guys enjoyed that. I think a lot of beginners they tend to think they know how to do it and then it doesn't quite work. Okay? And then some even stronger students, they realize what they're doing doesn't work, so then they're kind of stuck a lot more, but it's because they realize their thing doesn't work a lot more. So yeah. Alright guys, thanks for listening. So the exercise before the actual tournament, which is this Saturday, is to try to write a proof, how to convert this idea into a proof that it cannot be done with 74 attempts. Okay. Yeah. All right. You guys have any questions? Blake, Aiden, Lucas,
No.
you're good. Did it make sense?
Yeah.
Blake,
Yeah.
that makes sense.
Yes.
Oh, okay. Yeah, I guess one of those things. It kind of like I think it does make sense, but it doesn't necessarily make sense in the way people think it makes sense. Because there's a lot of issues that need to be resolved. You can't necessarily say everything. Some of the things were kind of a little bit left to your imagination, but the kind of the words were suggestive of how it should go. Okay. But this is about as close to a proof as you can get with someone just speaking ideas at you. Okay. So this is actually what solving the problem is like. Okay, more than writing the proof. All right, have a good one, guys. I'll see you next week.
All right. Thank you.
Thank you.
Bubble. 谢谢爸爸。It's like you know how so